Okay, welcome back. Today we're going to talk about rotation. Okay, so we already talked about a couple of the transformations. Today is rotation. Okay, a turning of a geometric figure about a point is the point is rotation. Okay, the point of rotation is a point about which the figure is turned. On a graph, the center of rotation will always be the origin for this class, or 0, 0. Okay? The number of degrees that a figure turns is called the degree of rotation. Okay? So, for this class, we were always going to rotate counterclockwise unless we tell you otherwise. So counterclockwise will go in this direction. Okay? Is rotation and isometry? Isometry. Yes. Because you're not changing the size, you're just changing the way that it moves. Now, we're going to go to the next question right here. All right, if I rotate 90 degrees, I am making one turn. All right? So I'm going to make get you the graph paper. Hold on one second. Let's see if I put it in here. No. Give me 1 second. Let me type this up. All right. Yes, I know that's big. I'm going to make it 821. Okay. All right. So if I start at this point, and I'm going to create this point so you all can see the term. This is point 2, 3, 2. Okay? That is at point 3, 2. Now, if I was to rotate it 90 degrees, okay, and I turn it 1 degree, turn it one turn counterclockwise, look at what happens there. That ordered pair is now, oh, whoops. That ordered pair is now at -2, 3. So instead of it being x, y, because remember our original was 3, 2, sorry, and now it's at -2, 3, what happened was it becomes -y, x. It's my new ordered pair. Do you see that it became -y and then the x side? Now, let's say I changed it and I rotated it again to 180. So I did 2 turns. Get this going so I can rotate it 2 times. So now let's look at it. It's now at -3, 2. So when you rotate it 2 turns, it becomes -x, y. Okay? And then if I rotate it 3 turns, that becomes -2, 3. So it's, I'm sorry, 2, negative 3, so it becomes y negative x. Okay? And if you do 4 turns, which is 360, you're right back at your original, 3, 2. Okay? Now, let's go ahead and let's graph these graphs and see what it would be if we do A, B, C, and D. I mean A, B, and C for this triangle. All right? I am only going to graph A, or I can graph them all. Negative 2, 1, 2, 3, 4. B is at negative 4. And C is at negative 3. Okay? Now, let's go ahead and rotate this 90 degrees. Whoops. Not letting me do that. What we're going to have to do is we're going to have to graph it on another graph. That's fine. I'm going to have to graph it on another graph. So let me do it again. So, A. I'll put A in blue. Negative 2, 1, 2, 3, 4. That's it. B is going to be at negative 4, 6. And C is going to be at negative 3, 3. Okay? Now, if I were to rotate this, I'll change my color on that. Negative 3. Let's see. This is really cute. No. Sorry, y'all. Still not right, but let's get that. All right? So let me go ahead and rotate these. So if I rotate it 90 degrees, boom. So my A is now at negative 4, 2. My B, I'm sorry, negative 4 and negative 2. My B is at 1, 2, 3, 4, 5, 6. Negative 6. Negative 6. Negative 4. And my C is at negative 3, negative 3. Now, let's go ahead and rotate it one more time. That's 180 degrees. My A is at 2, negative 4. My B is at 4, negative 6. And my C is at 3, negative 3. And then if I rotate it 270 degrees, my A is now at 4, 2. My B is at 6, 4. And my C is at 3, 3. Okay? Now, rotate regular polygon. The center is the same distance from every vertex. You also need to know that regular polygons can be divided into the number of congruent triangles, and that a central angle basically is the number of angles. Sorry, you don't even have to worry about central angles. Apologize. We're not doing that. So, practice at home. We already did a problem just like this, so you should have no issues with it. I just did it. Same with this one. The difference is this one you are going to go 90 degrees clockwise one turn. This one you're going to turn it clockwise while the other one you turn counterclockwise. All right? And in this image, PQ. If I turn PQ 90 degrees clockwise, that means I'm going in this direction. It would land right here where AB is. So my answer would be AB. If you don't believe me, let's look at it. Watch this. I'm going to take it and I'm going to draw this square. All right? And I'm going to rotate it 90 degrees clockwise. Oops, not doing the whole thing. Let me just do this. Oops. Hold tight. I just got to group this stuff together. Then I can put it back. All right, let's go back. So, now, if I take this and I rotate it 90 degrees clockwise, AB around O, I'm sorry. So if I do it around O, I'm like leaving my finger here. So it's not going to exactly match up, but you can see it. AB is going to, PQ is going to land on AB. If I was to do PS, it's going to go where AD is. Point P will go where? Point Q will go where? All right. That is the end of that video. I'll see you back in a second.